All right, guys. So let's rock and roll with the second law here. So, hey guys. So I am recording this right now. I will throw it up on my website in case people need to rewatch this incredible lecture here. Please understand, the first thing that I need you to really get about these laws is these laws are not independent of one another. So it's not like the first law is a totally separate law, that the second law has nothing to do with it. All three of these laws work with any object that has mass. Okay? So first and foremost, the second law is dealing with force, mass, and acceleration, which means that there is going to be an equation for it. All right, we're going to do a little bit of math with the second law here. So I think basically you understand here that a force is a push or a pull. A force is applied to an object to change its motion. That's what you should, that's the basic information of what you should get out of the first law of motion. Now, you also know, this is review here, acceleration is speeding up, slowing down, or changing directions. The math equation that we're going to use to solve problems for the second law is dealing with speeding up and slowing down. We're not going to get into acceleration in a circular motion. So we're going to stick with the algebra-based stuff. And again, mass is the amount of matter in an object. Got a little serenade out there. So again, all review here. So here's the equation, guys. This equation is not difficult. It's not difficult at all. It is a very simple algebraic equation where we can figure out either acceleration, force, or mass. Ultimately, in order to find acceleration, it is simply the force divided by the mass. You will also see this written. Force equals mass times acceleration. Okay? Based on being 11th graders, 12th graders, you should be able to rearrange this formula in order to solve for any of these variables. I could give you the mass and force, and you can solve for the acceleration. I can give you acceleration and force. You should be able to solve for mass. Okay? Gentlemen, I want you to separate. Thanks. Good. Who's moving? Eeny, meeny, miny, mo. Catch a tiger by the toe. If you always let him go. Eeny, meeny, miny, mo. You're going to move. You can sit back there by that computer. Thanks. So it says if both sides of the above equation are multiplied by the mass, the equation can be written this way. So that's what I just written above. Force equals mass times acceleration. All right? Now, just looking at this math formula, we can just dissect it and put it into words and understand what it says. So the force of this is mass times acceleration. Think of it this way. If you have a very heavy object, let's use the example that we just talked about in the packet. Hold on, Jordan, 1 second. Remember the Sally Short? Is that her name? Yeah. She had the two bricks, a massive brick and a small brick. All right? She pushed them with the same force. And Jordan told us when she answered the question that the one that's harder to move is going to be more massive. So therefore, the one that's more massive is going to be harder to accelerate. So in order, if you have a heavy brick and a small brick on a table, and you want to accelerate them at the same rate, you want to accelerate them at the same rate, which one do you have to apply more force to? Yeah, all right. So think of it this way. I'm going to do some incredible, let's see you later. So if we have okay, we have two bricks, like that. And we know F equals MA. We know F equals MA. I'm going to just use different size letters to show you greater and smaller values here. So we know that this brick is going to have a much bigger M. All right? Now, I'm going to say that we're going to use the same force to push these two bricks. So the F's are going to be the same size. How should I draw that A now? Yeah, very small. The acceleration is going to be tiny. If I use the same force to push this brick, I'm going to show that by this. Oh, that's horrible F. Same size F. It's got a very small mass. How should I draw the A? Very big. It's going to accelerate a lot more. All right? So mass and acceleration are dependent on one another based on the force exerted on the object. Okay? So here's a very basic math problem. A book with a mass of 2 kilograms is pushed along a table if the net force on the book is 1. So remember, guys, there is a net force, meaning there are unbalanced forces acting on it, which means the object is going to change its motion. That is what the first law says. So you can see how first law and the second law are tied in. All right? Yes, Jordan?
Dumb question, but what does net force mean?
Total. Total forces. The total amount of forces.
Net force.
Well, because it sounds nice. Do you have a job? Do you work?
Yes.
Do you ever look at your paycheck? It'll say net pay.
Yeah.
Net pay is your total pay. Total pay before taxes are taken out. All right?
Take out a lot of tax.
All right. So let's figure out what the acceleration is. Again, very simple. Acceleration, we know the force is 1, the mass is 2. So what's the total acceleration of it? There it is. 0.5 meters per second squared. Pretty simple, huh? Units of force is in newtons, which you should know after getting through the first law. Units for mass is in kilograms. So when you do these problems, guys, you have to understand that let's go back. That mass is going to be in kilograms. So if I give you a problem and I give you the mass of the object in grams, what are you going to have to do? Convert it to kilograms. Use the little conversion booklet that we made at the beginning of the year. And we know that acceleration, the unit is meters per second squared. Okay? So this here, 1 newton is equal to 1 kilogram meters per second squared. Pretty simple to understand here. If I just write down, if force is measured in newtons, mass is measured in kilograms, acceleration is in meters per second squared. That's F equals ma just by understanding the units of measurement. Okay? Yeah, the second law is not difficult. It's very common sense. You've all experienced it, and you've all done every single day you can think of or do an example of the second law of motion. Gravity and weight, again, we talked about this during the first law of motion. Gravity is the force of attraction that exists between any 2 objects that have mass. So any object, ultimately what this is saying is any object in the entire universe, any 2 objects, they will have a gravitational attraction towards one another. They will. Something as small, anything with mass. Oh, it's on record now. So something as small as a subatomic particle, does it have mass? Yes. All right. Something as large as a humongous planet, they will have a gravitational attraction towards one another because they have mass. Now, 2 things decipher how much gravitational attraction it is. The mass of the 2 objects and the distance between the 2. So obviously the closer objects are, the more gravitational attraction they'll have for one another. So there it is. So weight is a force, like the push of your hand is a force, and measured in newtons. So ultimately, yeah, I know we talk about pounds here in the United States, but since weight is a force in physics, it's going to be measured in newtons generally. The force of gravity causes all objects near Earth's surface to fall with an acceleration of 9.8 meters per second squared. We know that. We've dealt with that number since pretty much day 1. So your weight on Earth is the gravitational force between you and Earth. And we know this too, the difference between weight and mass. Again, this is just a quick little review here. Mass is not dependent on gravity. Mass is the same anywhere you go in the universe, where weight is totally dependent on the gravitational pull of the object you're closest to. This is the key here. It says weight will vary with location, but mass will remain constant. So if you go up, let's say you go to Colorado and go up Pikes Peak, your weight's going to be a little different than it is down in a valley. A little bit, okay? Because the gravitational pull is going to be different. So here we go. Here is what the second law here's what the second law states. We know what the second law mathematically states, but you can dissect the math equation to understand what it is saying. So it says an object acted upon by an unbalanced force will accelerate in the direction of the force. Yes, we know that. All right, and again, this super basic example of this eraser and me smacking it across the table. Yeah, there is an applied force for a split second when my hand hits it. When I'm done hitting it, it's still moving in that direction. It's accelerating. It's accelerating the whole time. When I hit it, all right, it's going to pick up speed, and the second that I'm done with the force, that applied force, friction is acting against it, and it's still accelerating it just in a negative way. So it's decelerating. All right? So if you kick the ball, it starts moving. The ball accelerates only while your foot is in contact with the ball. Now, that accelerates means picking up speed, but that ball will begin to decelerate the second your foot comes off that ball. And that is what Newton's second law is. Again, another very basic example. Suppose you pull a 10-kilogram sled so that the net force on the sled is 5 newtons. Well, you know the force is 5. You know that the mass is 10 kilograms. Therefore, it's going to accelerate. 5 divided by 10 is 0.5 meters per second squared. So you can figure out the accelerations of objects. Okay? I know I'm cruising through these here because I think it's pretty, second law is fairly basic. So explain Newton's second law of motion. Nope, I wanted you to do that, but I gave you the answer here. Yeah, so an object acted upon by an unbalanced force will accelerate in the direction of that force. The second law says that the acceleration of the object is equal to the net force on it divided by its mass. So ultimately, I don't care which one you remember. I think F equals ma generally is the way it's written that most people remember. So the mass and the acceleration of the object, those two combined is what's going to then give you the force of the object. All right? Larger the mass, the smaller the acceleration if the force remains the same. Yeah?
Couldn't you then just set up a force MA triangle?
You could. Absolutely. Good point. So think of it this way as well. We know that when we had speed equals distance divided by time, I had you guys do the triangle of S, D, and T. Well, we could figure this out as well. All right, we can make this into F equals ma triangle, where acceleration is going to equal force divided by mass. So therefore, this could now be acceleration. This will be force. And this will be mass. Yep. All right, question 2. You're blank on Earth. Is the gravitational force between you and Earth? Fill in the blank here, guys. Mass, not mass. Weight. Good. Your weight is the gravitational. Very good. All right. Very quick notes.